Okay, so the objective for today is functions. How do you evaluate them, functions in the real world, and then mathematically doing functions. Let's start with what are they? What are functions? I've got some examples here a little bit. You take some concept and put it into a function or some other concept, and then you can evaluate this new function at a different amount. And what you do with this is that helps you make plans, helps you make predictions about what's going to happen later. So some kind of value is going to go into one of these, function machines like we used to see before. Now the function can be a lot of things. You can take the X function, throw it in, that becomes your domain. And then maybe the function that we're throwing it into might be, it could be anything, 3x plus 2. And then you would plug that in and keep going out. And then maybe we might want to drop a 2 in there. So when we drop a 2 in there, that's when you're finding f at 2. So then you would plug in, your 2 for your x, and then get your output value. So what it really is your y. So in place of y, you're just putting f of x. Okay, so we're going to consider a real world example of this. What's our problem? We need to know how much money we're going to need for gas this week. So we're going to start with what we're going to throw in there, and then we're going to figure out our function and then go from there. What we're going to start with is D. So we're going to start with D. D stands for our days. That's our input value. And then we're going to let C at D. So we're going to throw it into a C function. What is a C function? The C function stands for the cost per week. That's how much it's going to cost you per week for your gas. And then your output is just going to be all the potential answers. Okay, you can use actual data to figure out these costs for the week. For example, if you were traveling 4 days, you have the function, the cost per day, but maybe you want to find out, you can do a lot of things with it. You can find a whole bunch of different things. A lot of people like to make the table. So if I put in 4 days, what would I get out? What would be the output? So I would be looking for C at 4, or you can put it at 7, or you can put it at a whole bunch of different numbers and evaluate down all the way. Then you can even go past a week and figure out, okay, how much would it be for the whole month, for 30 days? So then you would be finding C at 30. You're not really at this point finding an answer. You're just getting in your head what each function is and what it stands for. Okay, did you need to take an extra trip that wasn't even planned? Well, what you can do in that case is add 2 functions together. So you have the cost that you already had, but now you've got to make an extra trip. Just add that together. So the cost from that extra trip, it'd be some other function, and we add them together. Okay, say that you're going to not be going to work for 5 days, you're calling in sick. That's subtracting 2 functions because you won't be using the car all week. Another thing you can do, maybe you need to find your budget for the whole month. If you've got your budget for the week already out, because we know what that is, that's C of D. It already tells us this right here. So we already know what the cost for the week is. The cost for the week is C at D. The cost for week. So let's say that we wanted to find it for the month. Well, what would we do with this? Multiply it times 4. And then we would have the function for the whole month. Sometimes there's some weeks with more than 4, but you guys get the idea. Or if you're wanting to find the average of something, you have a larger amount, and then you want to find the average, like maybe per day of that week, then you can divide functions out. Okay, I'm about to go over to the next slide. Okay, let's see this in action. All you really need to know from here is you're taking something, in this case, days. We're throwing it into a function. What function are we throwing it into? The cost function. And then they named that C and D. What does that stand for? Cost per week. Right, let's go over to the next slide. Right, I'm going to start with addition and subtraction. Got the functions already written out. We're going to let P at T be the population of college students in hundreds. What does the T stand for? It's the years since 2010. Okay, what we got to talk about, let's just go for like backwards for just a second. T is the input value that's going to represent time. Well, we might want to know the amount using this function, for example, for the year 2015. Well, since that value was given to us in 2010, and then they want us to know the function in 2015, you're going to be looking for P at 5 because 2015 is 5 years away from 2010. So if you do happen to see a situation where they tell you up front how many years it's been, 2010, look at the new year that's given to you and subtract them out, and then that will end up being how many that you're going to evaluate that function at. So this is just a hint going backwards on evaluating functions. Okay, let's move forward with the adding and subtracting. Okay, so we know that P at T is everybody. That's all of the students. M at T is the number of the males. W at T is the number of the females. Also, both of them are in hundreds. Same thing at T years at the same time as 2010. All right, we're going to treat these as number 1 and number 2. Okay, number 1, find a function for the total students. Well, I know that the total students are made up of men and women. What are men? M at T. Total means plus, and then the women. And so as long as I add, well, I already messed that up. The men, and then we have the function for the women. So as long as I have the men and the women together, I have my total. So therefore, this is the final answer. There's really nothing else that we can do with that. That's all it asked me to do is just write a function for the total students. We're not solving anything. We're just writing a new function. Okay, number 2, find a function for the students that are not men. That are not men. I'm going to refer you over here to our picture. Remember, together as a whole, they're P at T. And the people that are not men are your women. And so we're going to have to take these men away from the total. What was the total? P at T. And we're taking away the men. How do you write men? M at T. And you're done. So that is adding and subtracting functions in the real world. So you're just showing how you can take two separate things and figure out how you can find total, how you might be, because sometimes we might not know how many men, but we might know the total. So you can write a function. That's what you would do anyway. If I told you, there's 100 students total, and then I told you that there were 60 of them that were men, what are you going to do in your head anyway? You're going to take those two functions, those two numbers, those two concepts, and I hope that what you're going to do is subtract them. And so all that really means is the same thing as what I wrote over here. We just don't know how many it is. They didn't tell us how many. They didn't tell us 100. They didn't tell us 60. They just told us what the function stood for. So there's adding and subtracting of functions in the real world. Okay, we have here, we're actually going to solve some out. They've told us that the number of males at the college is going to be modeled by this. I'll show you what that kind of means. We started, if this was 50, 100, 150. Remember, this is y equals mx plus b. Remember that function is really y. So my y-intercept is 110, and then it's showing me this slope, a slight slope. So this is, gradually going up. And then we have the females that started at a y-intercept of 40, and they are gradually going up. These people are going up at a rate of positive 1.42, and then the females are going up at a rate of positive 1.2. And all this is taking place in T years since 2010. Okay, so it says to find a function T at T. So we've got this brand new function that we're going to name that's going to represent in hundreds of people the total number of students at the college. Total number of students at the college. Well, I remember what that is. That's my males plus all the women. Well, we don't have to write it like this anymore. We actually know what the function is. Let me go ahead and write that out. I have 1.42t plus 110. That's for the males. And then I'm going to add that to the function of the women. Nothing is done until it is simplified. We have some like terms that we can put together. And remember, they already told us what our new function was going to be named. They said it was going to be named T at T. So therefore, T at T is 2.62T plus 150. Final answer. Okay, we'll name that number one. And on to number two. Use this function to determine the number of students in 2014. This is a model of what was happening up until 2010. And so now they want the total number of students. I'm using these models or using this new function for total in 2014. So we have the function, and we are going to find it in 2014. We started at 2010. So that means they want this 4 years ahead. So therefore, I'm finding that T function at 4. Remember, I already wrote it above. So I have 2.62 times 4 plus 150. So T at 4 is equal to, and I'm going to go to my calculator and I will be right back. We are going to get a total of 160.48. And don't forget what they told us. Don't forget that this was hundreds of people. So it's 160.48 hundreds of total students in 2014. This is just a projection. It's just a prediction. Things could happen. COVID could hit between 2010 and 2014. So therefore, things could really change. But if everything follows at a steady pace, according to these models that they've given us, then they use that for predictions for later, because you obviously don't know what's going to already happen in 2014 if you're just in 2010. So you use these to figure out some things in the future. Okay, so here we have functions that are not given out like a word problem. They're given out differently. The first one, they want us to add f plus g. So if I look at my f function, look at my g function, and add like terms, I will get 2x squared plus 7x. What I might want to do is once I use it, I'm going to cross it out. And then 5 minus 5 is 0. And so I have added all the way across. B, if I want to add all the way across, I have a cubed, x cubed. My squareds, negative 3 plus 8 is positive 5. 13 minus 2 is positive 11. Okay, when subtracting, number 2 over here wants g minus f. Okay, so g is 4 minus f. I'm going to put f in parentheses so I can keep it together. And then there's a rule that says keep the first, change the subtraction to plus, and then change the sign of everything after that. So now I'm in a situation where I am just adding two functions together. So final answer is a negative 6x squared. That one's gone. I put my 4 and negative 3 together, and that gives me positive 1. Okay, down here for B, it wanted me to take f minus g, and I've crossed them off. Let me erase that. Okay, so the f function, I'll write that first, is negative 3x squared plus 13. Then they want me to subtract x cubed plus 8x squared minus 2. I'm going to go ahead and rewrite it in an addition problem. And then next is to simplify and combine like terms. I have a negative x cubed. My x squareds together, I have a negative 3 and a negative 8. Same sign, add, and keep the sign. And I'm going to cross off what I've used. Visually, I just think it makes it easier. And then I'm left with just the constants of 13 and positive 2. And then I get my final answer. So if the function is given, all you do is just combine like terms for addition. On subtraction, change it to addition, change all the signs after the subtraction, and then add them just like you did on addition. If they don't give you the function, then they will give you the letter of the function. So you can still write the new function. It just won't have numbers and stuff in it like what we did before. So here's two different versions of it. Seeing it mathematically, one could be in the word problem type way, or it could be given with just the functions here with no word problem. Okay, this time we are headed to a real world example of functions with multiplication and division. On this one, I have P of W is going to be the price of gas that you would pay per gallon during some week. Doesn't matter which week. You could even do this, for different amount of weeks. Now, look at my graphs over there. You can see how it fluctuates. Obviously, gas goes up, down, over the years. If you were to monitor it, I'm sure it steadily goes up. Might take a dip every now and then. How much are you going to pay per gallon? That's P of W. Now remember back to the beginning when we talked about what is functions. Okay, let's take that P of W and go backwards. Let's go backwards and see how this could relate to evaluating a function. Because remember, they didn't really give us the function. All they told us was P of W. Okay, so what is W? W is going to put the input value that represents week. So they're going to give me some P of something, and I'm going to be throwing in a W. What is the W? The weeks. So I might want to know how much I'm going to spend for 3 weeks, 5 weeks, Maybe I might even want to know for the whole year. Well, that'd be 52 weeks. So however many weeks that you're going to throw into the function, then that's what you would substitute in for your W. So thoughts here. Would the price of gas per gallon, would you want it to be a consistent positive slope? A consistent positive slope. Look at this graph over here. This graph over here is going up, down, up, down. No, this slope is not consistent. This slope changes all the time. If I had a graph of gas prices with a consistent slope, then that means it would never go down. It would keep increasing at the exact same rate. So thoughts on that? No. We would not want gas prices to increase at a consistent slope. We do want them to go down every once in a while. So keep that in mind because you want to visually know what's going on. By the way, if it does do this, then that means it is a linear equation. Everything will be in the first power. All right. So let's head back to, that's just a little bit of evaluating functions and what does this really mean? Look at what they give you first of all, and then think, okay, I'm going to then think back, what does this really mean? What it really means is what you're used to when you plugged in all those values of W. They made you find, let's find it at 1, let's find it at 2, let's find it at 3. Those are your weeks. And you plugged them into something and then you got an answer. Well, that's your output. So there's several different things you can do with that function P. All right, let's head back to multiplication and division. Okay, so we know what P of W is. P of W is the price per gallon that you're going to be paying during some week. Okay, so I'm going to add some extra functions into the mix. I'm going to let G of W be the number of gallons that your car is going to need. We know how much it costs, but we don't know how much you're driving. Okay, let T of W be the total cost of gas during the week. So maybe we already know the total, but maybe we don't know what the price per gallon is, for example. So keep in your mind what every single one of these mean. Every time you read these things, they're always going to tell you what it means. They're always going to tell you what these function notation, these are actually called function. These little things are called function notation. I guess the whole point is, can you read the function notation? Can you understand how to read it? All right, so we know the price per gallon. We know G of W is how many gallons you're going to need in your car. T of W is going to be the total cost that you're going to be using during the week. All right, number 1 says find a function for the total cost of gas used by your car during the week. Total cost. Well, we already know the price per gallon. That's P of W. That might be, $3.58. Well, then we're going to take that $3.58 and multiply it by how many gallons we're putting in our car. Is that not correct? We're going to multiply it by how many gallons. Well, how many gallons is it? G of W. That's what they told us that gallons was. Now, we don't use the X at this level, so I would rewrite this. A lot of times you just really see them side by side. And that is multiplication of functions. Multiplication of functions. Now it asks us to find a function for the average amount of price per gallon during the week. Price per gallon. This per word is going to be the thing that saves your life. The per word, per. Because if you go back to that concept of ratios, when we said, miles per hour, you learn that you can write those a lot of ways. You can write them on top of each other. It looks like a fraction. You can write them with the word to, or you can write them with the colon. But this line right here means per. So if you follow the things, you can see that first, if you want price per gallon, then price better be your numerator and gallon better be your denominator. Okay, what is the price? What's the average amount of price per gallon? We know our total. We know our total that we spent. That's T of W. And then what are we going to find out? The price per gallon is your P of W, because G of W is how many gallons your car is going to take. There is a way to rewrite these. Can do this. And then put the W out here. Okay, find a function for the average amount of gallons used during the week. So we know how much we paid, but this time they're flipping it. They want to know the actual gallons that your car took. So this time we're going to be dividing by the gallons. And again, you can rewrite this the same way. So if you see the word average, look for the word average. Look for your pers, because it could be that the per will give you indication to what goes in your numerator, what goes in your denominator. If you're looking for average of a total price, then one of your functions is probably going to be the total. Okay, here is multiplying and dividing mathematically. So we're actually given the function this time. I'm going to start with the division, because the division is very simple, because here they want the F function on the G function. So I literally put the F function in the numerator, the G function in the denominator. And since this is a fraction, I might want to think about, does it simplify? So I am going to go over to the side just to see if this simplifies, because I can already see that I've got a GCF I can pull out, and I have an X minus 3. And then I'm going to see if that bottom will factor. I'm going to check it out and see if it will. I know I've got a 3 and 2. Okay, so I have factored this out, and simplifying, we have 2 of the same factors. So this actually will simplify to 2 over X minus 2. Final answer. I'm going to head down to the other division problem. This one tells me they want G on top, and then they want F on the bottom. Same thing, I'm going to check to see if it simplifies. Going to factor it out. And I don't like a negative A, so I'm going to do a little bit of changing here. I'm going to stick the -1 out front, but I'm going to change that whole top to the opposite. Go ahead and do my GCF on the bottom. Then I'm going to see if my top will factor. Okay, so I've factored. I do have a common factor here. And so I am left with the final answer of that -1 is still there. But watch how I write it, because I do have a factor on the top of X minus 4. So I have a negative X minus 4 over 4. I almost would change, I don't know, you could change this to even say negative X plus 4 over 4. Those are the same 2 things. These 2 have the same value. Okay, so there's division. Next, I'm headed to multiplication. Multiplication, this one says G times F. So I have G is a binomial. So this is really like saying X cubed plus X squared times -7X plus 2. I'm going to do this one with box method. This one is a 2 by 2. Write my binomials across the top and the side. And then I multiply to fill in. And my diagonals are my like terms, and then I'm ready for my final answer. So the final answer to this one is negative 7x fourth. If I combine these two terms, I have a negative 5x cubed. And then on the end, I have a positive 2x squared. Final answer. And I'm going to get this next one set up. This next one wants us to do f times g. However, it's a trinomial times a binomial. Trinomial times a binomial. You can still use box method for this. Okay, so I've got my box ready. You multiply it to fill in. Okay, I do have my diagonals here that are my like terms. I'm going to go ahead and circle them. And then I'm ready to write my final answer. Final answer. And these are the functions multiplied together. And this also shows you a little bit of the trinomial in a different version of FOIL. This is multiplication and division of functions mathematically. That ends our lesson on what functions are, and then function operations with add, subtract, multiply, or divide. So at this time, I will take any questions if you have any questions. Otherwise, thanks for being with me and learning. Hello.
You broke it down very well because now I understand how to get like the functions correctly.
Yes, y'all saw those on the midterm and didn't really know what they meant.
Yeah.
Now you know what they mean.
Yeah, because the midterm, I was kind of confused how to get the right answer. So you broke it down to where I can figure it out easily.
Thank you. Perfect. That was my point.